This is question number 32 from Unit 5, Lesson 3, Day 4 homework. This is on page 388 of your text. And it looks like we're going to rewrite each expression in a simpler equivalent form. And so we have, for the first part, we have 108 divided by 16. A simpler equivalent form would be to reduce the fraction if we can. So you might look at this and go, well, I don't know how to do 108 divided by 16. Well, maybe you don't, but maybe you can simplify with 2's instead. Can you divide 108 by 2 and 16 by 2? Certainly. If I take half of 108, I have 54, and then half of 16 is going to be 8. So that's one simpler form, but you might still see that, wait a minute, there's a 54 and an 8. I could divide both of those by 2 as well. So let's do that. 54 divided by 2, well, 50 divided by 2 is 25, and half of 4 is 2, so I actually get 27 out of there. And then half of 8 is 4, so I have 27 fourths. That's equivalent. We'll leave it at that. B, we get 3x plus 12 divided by 3, the whole thing divided by 3. Well, the nice about taking this whole expression and dividing by 3 is that we can actually separate this as two separate fractions, too. We can write it as 3x over 3 plus 12 over 3, which 3x over 3 will simplify to x, and 12 over 3 simplifies to 4. So this is the same as saying x plus 4. For part C, we have 10x squared minus 8 over 24. I'm going to do the same thing that I did in part B. I'm going to separate these out as two fractions. So this becomes 10x squared over 24 minus 8 over 24. What I can do then is rewrite 10 over 24 as 5 over 12, just dividing both by 2, x squared. And then 8 24ths, I know 8 goes in 24 3 times. This is 1/3. So that's one way to write this. We could also have gone back to the original one and said, let's leave it as one fraction, but maybe divide everything by a common factor. But a common factor of 10, 8, and 24 would only be to go with 2 here. So if I do that, this would have to be 5x squared minus 4 all over 12. That would be equivalent as well, and it would lead to the same results of 5x squared over 12 minus 4 over 12, which is 5x squared over 12 minus 1/3. See, it's the same thing, so no worries about that. Now, the review is supposed to have you go 31 through 36, so I'm just going to keep going. We're going to do 33 as well. It says Billy is standing 80 feet from the base of a building. The angle of elevation to the top of the building is 35 degrees. If the distance from Billy's eyes to the ground is 5 feet, how tall is the building? So we're going back to some trigonometry here. We have a building that's standing up, right? And where Billy is standing 80 feet from the base of the building. So we'll put Billy here, 80 feet away. And we're told that the angle of elevation to the top of the building is 35 degrees. If the distance from his eyes to the ground is 5 feet, so he's looking from the ground, this is 5 feet. And we have this angle here of 35 degrees. We're supposed to find the height of the building. So what we're going to do is use the angle and use this 80 feet. And the fact that the building's probably standing straight up and down, we can assume that. We'll make a little right triangle trigonometry problem here, where we want the side that is opposite to 35, and we have the side that's adjacent. Opposite, adjacent, that is going to be a tangent function. So we'll write tangent of 35 degrees equals the opposite side we want divided by the 80 feet. So to solve this, we'll multiply by 80. So 80 times the tangent of 35 equals the opposite side. And then what we'd have to do is we'd have to add 5 feet to this, right? Because we have the 5 feet of the person who's standing there, Billy. So we'll add 5 feet to the answer to that. And now I'll pull out my calculator. And we actually have to go back to degree mode. We haven't done that in a while. So underneath menu, you could probably go to setup, or if I go to documents and I go to settings and status, document settings, I can see that this is going to be in a degree mode this time. And maybe I'll put that as default for now. Okay, but then I want to make sure that I'm using documents as well. So I'm going to do a new document, and I'm going to not save the old one. I'm going to add a calculator. Oops, that was a spreadsheet. Okay, and so I want to do the trig value. We're going to do 80 tangent of 35. Enter, and I get 56.016. I'm going to add 5 feet for Billy. 61.0166. So this answer is 61.016 feet. Okay, let's keep going. We got 34. It says, consider the following statement. The diagonals of a rhombus are perpendicular. Write the statement in an if-then form. The diagonals of a rhombus are perpendicular. Okay, so we'll say is this. We'll say if a quadrilateral is a rhombus, then its diagonals are perpendicular. Okay? And it says, is this a true statement? Explain your reasoning. Okay, well we can start with the rhombus. I'm just sketching this by hand. And we're going to put in the diagonals, this one, and they appear to be perpendicular. Okay? But the question would be, how do we prove they're perpendicular? What we have to do is prove that these two triangles, if I make this triangle ABC, and I take ADC, if triangle ABC is congruent to triangle ADC, then we would have congruent parts of congruent figures, and then these would have to be summing to 180 and so on. So what I'm going to do is kind of fast forward a little bit here, and I know that these two sides are equivalent to each other. I remember some information about, this is a shared side, and on a rhombus there's information perhaps about a third side, or the fact that the diagonals of a rhombus bisect each other. So I remember that information as well, and so I can say something about how these two sides are matching as well. And when I do that, I actually have side triangle congruency. So when I have the congruency set up, I can then say that the angle ACB is congruent to angle ACD by the corresponding parts of congruent figures. That's an old one we haven't used in a while. And then we also know that the angle ACB and angle ACD are a linear pair. And then if they're a linear pair, then we can say the measure of angle ACB plus the measure of angle ACD equals 180. That's the linear pairs postulate. And if the linear pairs postulate means they sum to 180 and they're equivalent to each other, I now know that the measure of angle ACB equals the measure of angle ACD, which equals 90 degrees. There's a little substitution there. And then last, since they're equal to 90, we can now say that the lines are perpendicular. Diagonals are perpendicular. Okay, so that ends part A. Part B is being true. C says to write the converse. So we'll say if a quadrilateral is has perpendicular diagonals, then the quadrilateral is a rhombus. Well, I can think of one right now that would make this a false statement, because it asks is, part D is going to say, is this converse true or a false statement? And this is a false statement, because I can think of a quadrilateral that has perpendicular diagonals. There you go, just drew one. And this is by no means a, look at that, I didn't even use the rest of it. It looks like a kite though, right? So this is a kite, and this shows that they're perpendicular, but it's not a rhombus at all. That ends question 34. So this is questions 32 through 34.